Bam, Mr. True. Let's do some more proofs. Okay, we have the tangent squared x over secant of x equals secant minus cosine. Okay, well, how are we going to deal with this power of 2 on the left-hand side? You're not going to prove this identity if you can't get the degrees to be the same, and we can't divide it away. We can't square root it away, because those two math functions require that you have to work with both sides of the equation. So, what's to do? Well, I don't know. So, you can, and at this point, remember, these are proofs, not here's 5 steps, follow them in the right order, get the right answer. So I'm going to try something. If you don't like it, try something else. Maybe you'll do the proof quicker than me. Maybe I'll do it quicker than you. You know what? If the two sides match, who cares? Just as long as the algebra is correct all the way through it. So I see this this tangent squared x, and I don't see any tangent functions on the left-hand side. So I'm going to take out tangent squared x, and one of our identities are 1 plus tangent squared x equals secant squared x. And I'm going to use that Pythagorean identity to rewrite the numerator. I'm going to bring this 1 over to the other side and write the tangent squared x is equal to secant squared x minus 1. Okay, now your first step may have been to write this as sine over cosine, and this is 1 over cosine to start with, and that might be perfectly just fantastic, and maybe it's going to be a good proof. But that's what I've done first. So now I'm looking at my problem, and I still have a degree of 2, or over here is I have degrees of 1. And I don't see any way of canceling anything out, because remember, you cannot cancel terms, okay? My students like to say something like, well, can't the secants cancel out? Well, canceling this secant out with this secant would be like saying that this is okay. 4 plus 9 over 4. My kids might be recognizing this if they're watching it tonight, right? Okay, so could I cancel these 4's out? I mean, I've got a common thing on the top and bottom of this fraction, but it's a common term. And if I cancel out the 4's, 4 divided by 4 is equal to 1. And the last time I checked, 1 plus 9, which is 10, does not equal what is really 4 plus 9 over 4. 4 plus 9 is 13. The denominator is 4. And last time I checked, 13 over 4 was not equal to 10. You cannot cancel out terms. You hear me? You paying attention? Okay, good. Now, if it were multiplication, you could cancel out. You can cancel factors, but you cannot cancel terms. So, well, that's not going to cancel away. So what else is going on? Well, this is one term. A fraction bar is a grouping symbol. So we have one term on the left and 2 terms on the right. How can we take this fraction and break it up into 2 parts? Well, it's got 2 terms on top. So what you have is a subtraction of fractions with a common denominator. You don't believe me? How about 4/3 minus 1/3? Well, if you have a common denominator, don't you just subtract the numerators and write the common denominator once? Yeah, you do. So, what I'm going to do is, I'm going to take secant squared minus 1 and split those 2 terms up and give each one their own fraction with the common denominator of secant. So we've got secant squared x over secant minus 1 over secant. And I'm getting excited because now I can cancel the secants out, because this is secant times secant over secant. And secant times secant, when 2 things are multiplied together, then they're factors, not terms. So this 1 secant on the bottom will cancel out with one of the 2 secants on top. And you can think when you divide like bases, you subtract the exponents as well. And we get secant minus 1 over secant, 1 over secant, reciprocal function. Yeah, you're right. That is cosine, and that's a match. Woo! All right, going on to the next one. Okie dokie. So the next proof we're going to take a look at, or identity we're going to try and verify, is the cosine of negative theta over 1 plus the sine of negative theta equals the secant of theta plus the tangent of theta. Well, on this particular proof or identity that we're going to attempt to verify, my angle measures are not the same. Now, they're very close, but they're not equal. Instead of theta, we have negative theta. So we have opposite angles. Well, now that talks about a chapter 1 concept from my book. You might remember it from the previous video. If you're watching these in sequence, we needed to discuss the idea of even and odd functions. Cosine. The cosine graph starts on the y-axis at 1 and falls in both directions. So the cosine graph is symmetric to the y-axis, which means that if you plug in opposite x's, you get out the same y value. So cosine is an even function. If you're not sure what even functions are, even and odd functions, you'll need to go back and review that concept. You've already covered it in your class if you're doing pre-calculus. The cosine of an angle is equal to the cosine of that opposite angle. It's an even function. So the cosine of negative theta is equal to the cosine of theta. Cosine, again, is symmetric to the y-axis, so it's even. Whereas sine is not symmetric to the y-axis. Sine has origin symmetry. If you were to go look in your book for a parent function of sine and take it and rotate it 180 degrees, you know what the difference is? All the numbers are upside down. Besides that, nothing. Sine is an odd function, and that means that when you plug in an opposite angle, so I want to write this as the sine of theta, not negative theta, so I'm going to plug in an opposite angle. When you plug in opposite values, you get out opposite answers. So the sine of negative theta is going to be the opposite of the sine of positive theta. So if I plug in an opposite value, I'm going to get out an opposite answer. All right, so now we've got our two sides matching. And I'm going to go ahead and stop working with the left-hand side because sine and cosine are the building block trig functions. There's nothing else I can do. I can't write, well, I guess I could, but I'm going to try and simplify instead of making these more complicated. I'm going to write secant and tangent in terms of sine and cosine, and hopefully something nice happens. Let's see what happens. Shall we? Okay, so secant is 1 over cosine of theta. Oh, God, I just laughed at my own joke. That's terrible. Tangent is sine over theta. What's worse is it wasn't even really a joke. And, okay, well now we have common denominators. So on this side, we've got 1 plus sine theta over cosine theta. Well, now both sides have the building block core trig functions, and wow, I don't know. You guys have any ideas? Yeah? Okay. Well, this side, I like that idea. We got 1 minus sine over on this, the right side of the proof, and I'm going to start working with the right side. I got 1 minus sine on the bottom of the fraction on the left side of my identity, and I'm going to start working with the right side because I have more room, and I think I'm going to need a few more steps. Thank you for the suggestion. So I want a 1 minus sine in this fraction. Now I just said you can't move things over from one side of an equation, or excuse me, identity, to the other. So I'm not going to multiply both sides by 1 minus sine theta because that would be moving it from one side to the other. But what I am going to do is multiply this fraction by 1. Just a funny looking one. I'm going to multiply it by 1 minus sine theta over 1 minus sine theta. That is 1, right? See? I'm multiplying by 1? Okay. What happens? Well, this is what happens. We're going to have 1 times 1 is 1, 1 times negative sine, and then positive sine times 1, and then negative positive sine times negative sine. This is a difference of squares pattern. So when I distribute this, I'm going to get 1 times 1 is 1, then I have negative sine and positive sine. Those are going to cancel out, and positive sine times negative sine is negative sine squared theta, all over cosine theta times 1 minus sine theta. And I'm not going to cancel, or excuse me, I'm not going to distribute this stuff together because I need to do some canceling. See my power of 2 that's showing up? I'm going to have to do some kind of canceling to make it match this left-hand side. So I'm thinking if I leave the bottom in factored form, that's going to save me some work. Okay, my numerator is full of the sine function, This numerator is only got cosine. I'm not going to get these to match if I don't get the top of the fractions to have the same trig functions in them. So the first Pythagorean theorem that says sine squared plus cosine squared equals 1, if the angles are the same, I should not be leaving theta out, says that if I take 1 minus sine squared theta and substitute it using that first Pythagorean identity, 1 minus sine squared theta is equal to cosine squared theta. Okay, now look. I got one term on top and it's cosine. I got one term on top and it's cosine. I got a 1 minus sign on the bottom. I got a 1 minus sign on the bottom. So close! Oh, I can cancel these factors out. So, one of those cosines on the bottom, that factor, it's multiplied to something else, not added. That cosine on the bottom is going to cancel out with 2, or one of the 2 cosines on top. And look at there! Look at there! Cosine theta over 1 minus sine, whoops, that's not a 5, sine theta. Is that a match? Is that a match? Yeah, it is! Woo! Alright, let's do another one. I love this stuff. You just kind of try different things and do some different substitutions, and then all of a sudden the algebra starts going, hey, 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 you're getting close to the answer. Okay, we got 1 plus cosecant theta over secant theta minus cotangent of theta equals cosine. Now, I got a lot going on the left-hand side. Remember, work your way down the tree and you'll land or come down that one trunk. Don't make things more complicated. Don't try and make this one term into 2 terms and somehow add in cotangents and secants into just the simple cosine function. So start with the left, figure it out. I only have cosine, I don't have cosecants, I don't have secants, and I don't have cotangents. So I'm going to go ahead and make the left-hand side in terms of sine and cosine right off the bat. So we got 1 plus 1 over sine theta over 1 over cosine theta minus cotangent, which is cosine theta over sine. Now, that looks worse. So we're going to have to start cleaning up this first fraction and see if anything nice happens with this second fraction when we're done. So we're going to find a common denominator between 1 and sine is going to be sine. So we're going to multiply this by sine theta on the top and bottom. And we got our common denominator now, so I'm going to do sine plus 1, sine theta plus 1, over sine, over cosine theta, minus cosine theta over sine. Now this bottom fraction is going to get flipped up, and we're going to get, and this is going to sit here, we're going to get sine theta plus 1 over sine, and the cosine got flipped up, so it's going to be, whoops, miscopied it. That was 1 over cosine, sorry about that. That's going to get flipped up and be sine theta plus 1 times cosine over sine. Again, this bottom gets flipped up. The second fraction already has a sign in the denominator. Now look, we've got sine theta plus 1 times cosine minus cosine over sine. And our final goals have nothing but cosine left. Well, if I take out the cosine from these 2 terms, because these are going to come together as one big fraction, let me just write it like that, since we have a common denominator of sine. These 2 terms both have a cosine. So if I take that cosine and I factor it out, sine plus 1 times cosine with the cosine out is going to be sine theta plus 1. And if I take the cosine out of this term, cosine again divided by cosine is 1, but it's minus 1 over sine. Well, I'm running out of room, but we're also almost done. 1 minus 1 is 0. Now we've got cosine times sine over sine of theta. And I almost made a mistake, but I do think we finished in time. Bam, the sines cancel out. And we get the cosine of theta, which now that I'm in a hurry, I'm making a couple of mistakes here. Let me fill that back in, and bam! Cosine theta from the left equals cosine theta from the right. I'm Mr. Tarut. Go do your homework.